Good morning. Today we are continuing with our Unit 6, working on algebraic expressions. We are doing CO34. I can simplify algebraic expressions. So let's look at some of the vocabulary that we need to know. First thing is the terms, the parts of an expression that are added together. So the terms of 2x plus 3 would be 2x and 3. So those are the terms in our expression. Like terms, terms that have identical variable parts, two or more constant terms are considered like terms. So in the expression x plus 4 minus 2x plus 1, x and 2x are like terms. They both have the x. So those are like terms. Then we have 4 and 1 are like terms. They are constant. They don't have a variable next to them. So either they don't have any variable at all, they're similar, 4, 1, they're both just whole numbers. Or they have the same letter. That x is the same. So they are like terms because they're both x's. An equivalent variable expression are expressions that are equal for every value of each variable they contain. So 5 times x minus 3 is the same as 5x minus 15. They are equivalent variable expressions. So we could say all they were doing was multiplying that 5 through the parentheses. Please stop with your feet. So 5 times x minus 3 is 5 times x, 5x, and 5 times negative 3, which would be that negative 15. So the coefficient is the number in a term that is the product of a number and a variable. The coefficient of 7x is 7. So that's that number that's right in front of your variable. We call that the coefficient. So that's the number, not the letter. Coefficient is the number. The variable is the letter. The coefficient is the number. A constant term, a term that has a number but no variable. So if we look at 5y plus 9, 9 is the constant. There's no letter next to it. So the constant is just the number. It doesn't have a letter. We know it's a constant. So those are a lot of terms that we're going to be using. So this is an important objective for you to hold on to and make sure you refer back to it so you know what the terms are, what the like terms are, what an equivalent expression means, what a coefficient means, what a constant means. So you need to know those vocabulary. You will see that vocabulary in the future in the directions. They might use these terms and you need to know what they mean. So make sure that you refer back to it if you forget. All right, let's look at what we're learning about today. The distributive property. It can be used to simplify a variable expression. So 2x plus 3x, it's the same as saying 2 plus 3, and we're keeping that x. So 2x plus 3x, the way I learned it was 2x plus 3x, that x stays the same because they're the variable. 2 plus 3 is 5. What you're doing is you're using that distributive property. You're taking that x out. 2x plus 3x, you're taking the x out, putting it on the outside, and doing the math on the inside. 2 plus 3. We know 2 plus 3 is 5. And you put that x on it because it's 5 times x. The parts of an expression that are being added together, such as 2x and 3x in the expression 2x plus 3x, are called terms. Terms that have identical variable parts are like terms. In the expression 2x plus 3x, 2x and 3x are like terms. The distributive property allows you to combine the like terms. So let's look at example 1. Simplify the expression 7c plus 9 minus 3c. So what are our like terms in that? 7c plus 9 minus 3c, lowercase c. What are the like terms? Free out. What is like 9? What is that similar to? Remember, the like terms are the terms that have either the same variable or no variable at all. So which ones have the same variable? 7c and 3c. They're both c's. So we can combine our c variables. So we have 7c minus 3c. So if we take that c out, oops, we have 7 minus 3c. Right? Mm-hmm. Yes. We're going to get to that. So 7 minus 3 is 4c. And Zoe said, well, what about that 9? Well, that 9 is still here. So we have 4c.
Now we just add the 9.
Plus 9. If we look at how we worked it out over on this side, we had 7c plus 9 plus negative 3c. They put that parentheses there, so we knew it was a negative 3c. So we have 7c plus negative 3c. It's the same as saying 7 minus 3. So 7 plus the negative is the same as just saying 7 minus. So 7 plus the negative 3 got us that 4c. Oh, I forgot to put the c right here. There should have been a c there. So we have that 4c, and we still have that plus 9. So it's still a part of that equation. Yes?
And then, would you do the math for that? Put the 4c plus 9? Or would you just
If they say simplify the expression, this is all you have to do. You don't have to solve it for c.
Okay.
If they say evaluate, simplify the expression and evaluate, then you have to do the math.
Okay.
Simplifying it, we're just making it so it's a lot simpler to do. I think on this objective, we're just working on that simplifying, and then the evaluating is coming next. All right, let's look at our next section. So in example 1, 7c plus 9 minus 3c is equivalent to 4c plus 9. We simplified it down. In a term that is the product of a number and a variable, the number is called the coefficient of the variable. A term that has a number but no variable is a constant term. In the expression 4a plus 1, remember that coefficient is the number right in front of your variable. The constant does not have a variable. So coefficient's the number in front of the variable. If it's a constant, there's no variable. So constants are like terms. And if the variable is the same, those are like terms. So coefficients, constant terms, and like terms. Identify the coefficients, the constant terms, and the like terms. So look at x plus 4 minus 2x minus 10. What are the coefficients? Remembering that a coefficient is the number in front of a variable. What are our coefficients? Josie? We see that 2 in front of the x, that is a coefficient. Does anybody know if we just have an x, what would be the coefficient there that we don't see? Any guess? Brielle? Not a 2. Okay.
1.
Why 1?
I don't know. It was just really a guess. Yeah.
What is 1 times a number?
Itself.
It's that number. So if we put a 5 in for x, and we did 1 times x, it would be 5 still. But if we're going to combine our like terms, and we have x, let's say it was plus 2x, we're going to keep it simple, and I have to pull out my coefficients to add together, I need to have a number there to add to my 2. So that's when you put a 1 in, so we know it's 1 plus 2 times x. So it would be 3x. So if you have just the variable, know that there's a 1 in front of it. We don't have to write the 1 normally because a number times 1 is itself. So we don't have to do that extra step, but we do when we're combining our like terms. So you need to know that if it's just a variable, there's a 1 in front of it. So you have to put that 1 in when you're combining them. Make sense? What are our other, that was the coefficient. So what is our constant terms? We know the coefficients. What are the constants? Lily?
10 and 4.
10 and 4. Constants don't have any letters next to them. So the constants are the numbers that have no letters next to it, no variables. So now it says, what are our like terms? What can we combine? What are the like terms? What goes with what, Nolan?
I just daydreaming.
Yeah, so look at that. 1x plus 4 minus 2x minus 10. What can I combine together? Which ones are the same?
What's the same?
Which terms are the same, Nolan?
The subtraction?
Not operation. So your term, we did coefficients, we did constant terms, and now we're doing the like terms. I've actually underlined the ones that are the same.
Oh, 10 and 4.
10 and 4 are both constant terms, so they are like terms. We can combine them. What else can we combine, Landon?
1 and 2.
The 1x and 2x. Those are like terms. They both have an x. So we can combine them. Could I combine 1x and 4? No, they're not like terms. You can only combine things that are the same, that are like. They either have the same variable letter or they have no variable. So let's look at example 3, simplifying an expression. How can we simplify 5 times w minus 4 plus w plus 8? What do you think our first step should be here? Anthony? We have to look at that parentheses. We need to take out the parentheses. So thinking about that distributive property, what can I change that into? 5 times w minus 4. How could I rewrite that? Anthony? Remember, 5 on the outside of the parentheses means what? Multiply. So we want to multiply that 5 through our parentheses. Anthony? Say that again. How did you get that?
Because W is like 1, and then 1 minus 4.
We're not doing the -4 because W and 4 are not constant. Or sorry, they're not like. We can't combine them. Because one has a W and one does not. So you cannot combine them. What we have to do is we have to multiply that 5 through the parentheses so we can get rid of the parentheses. So we have to multiply 5 times W. So that would be 5W. Minus, what's 5 times 4? 5 times 4. Well, 20. And then we have our plus W plus 8. Now can I combine like terms?
Yes.
Now it's a whole lot easier to combine our like terms. What is one set of like terms, Nolan?
Is it
Remember our like terms. We have an X and an X, I can combine them.
Oh wait, wait, 20 and 8?
Yeah, good job.
Good job.
Negative 20 and 8 are both constant terms. There's no variable, so I can combine them. So if I had negative 20 plus 8, what does that become? Will?
Negative 28. Oh, never mind. Negative 12.
Yes, negative 20 plus 8 becomes negative 12. What other like terms do I have, Kira?
5 and 1.
Tell me the whole term.
You have to have 5W and 1W.
5W and 1W. Because I have a plus sign in front of this W, I know it's going to be a plus here. What is 5W plus 1W, Kira? 6W. And minus 12. Do we see how we did that? The first step was getting rid of our parentheses. We had to multiply that 5 by everything in the parentheses. Then, listening, Nolan. Listening, Peyton. Listening, Will. Your first step is getting rid of the parentheses, multiplying the 5 through. Then you're combining those like terms to get your simplified expression. (6W minus 12). Okay? So then, if they tell us what W is, we can plug that in and solve it. Writing and simplifying an expression. A rectangular mat is twice as long as it is wide. Write and simplify an expression for the perimeter of the mat in the terms of width, W. So who thinks they can do that? I'm looking at you, Ryan.
You haven't answered anything, no? Number 4.
So think about it. We have a rectangle. We have a rectangle. It's twice as long as it is wide. So what do you think I should put for wide? What should I put? Width. I would put what? W. What am I going to put for the length? If it's twice as long as it is wide. What should I write if it's twice as long? Think about what we were doing yesterday. If it's twice as long, are we adding, subtracting, multiplying, or dividing? If you're doing twice, remember our terms yesterday, you're multiplying. Multiplying what number? If it's twice as long. Twice means how many? You're multiplying it by 2. What am I going to multiply by 2 if it's twice as long as it is wide? By the W. Now we want to find the perimeter. How do we find the perimeter? Anthony?
Add all the sides.
Add all the sides. So I need to fill in all of my sides. So I have 2W and a W. And I need to add them all up for the perimeter. Shh, gentlemen. So we have W plus 2W plus W plus 2W. How can I simplify that expression? Nolan.
Like terms?
Yeah, what are my like terms?
Oh, 2W and 2W.
What else goes with it, Landon? Yeah, what number do I put in front of my W? Remember, those are ones in front. So all of my terms are like. So I'm going to add all these numbers together. 1 plus 2 plus 1 plus 2. And then I multiply that by that W. What is 1 plus 2 plus 1 plus 2? Will? 6. And then I have that W. So my simplified expression is 6W. So we just take it one step at a time. Questions? Okay, we're going to go through the workbook page to see how we're doing. Our workbook page for this objective is 85 and 86. So page 85 and 86. For my friends at home, if you have questions, reach out to me. I hope you are doing well, and we see you soon.